From our single table query section, we learned that doing select star from employee does two things. Number 1, select star shows all fields. From employee chooses the table. Since there's no where condition, the from gets to show all the records from the table. If we add a where clause after the from clause, we can limit the number of records we see. In this case, saying where location ID equals 1 limits half the records. We only get 6 of the 12 records in our result set. If our equal sign is looking for a very precise match, it's possible that your where clause will have a condition so specific that you only get 1 record in your result set. In this lab, we're going to explore the use of more criteria possibilities that come after your where clause. We're going to explore more operators than just the precise equal sign in finding matches you're looking for. Here's another example of a very precise piece of criteria that comes after your where clause. If you select all employees where the first name is Barry, you get 1 record. Now, there's more than one employee whose first name starts with the letter B. Erasing every letter after B gives us no records, because the equal sign is looking for an exact match. In other words, everybody whose name is B. However, if you change the equal sign to a less precise operator called like, and then say B, it still doesn't work until you put what is known as a wildcard. The percent sign can mean any number of letters and any type of letters. Let's execute. And notice, you get Barbara and Barry. If you understand that the percent sign is a flexible way to find any number of characters and any type of characters to look for patterns, but you're wondering what is meant by an equal sign is a precise operator and the like is an approximate operator, look at these 2 queries. We're going to start off with first name equals single quote B percent single quote and run it. And you'd expect to see Barry and Barbara, but you get nobody because the equal sign is looking for a name exactly B percent and nobody has that name. By changing the equal sign to a like operator, we get the results we saw from just a few moments ago. The wildcard trick can be used with other letters too. Let's look at all of our employees first. We have 12 employees. Now we have some employees who have the first name starting with the letter E, and we could easily look through and see who they are, but let's let SQL Server tell us. Put where, first name, like, single quote, E, percent, single quote, and execute your query. And you see we get 1 result, Eric. Now we don't have to just look for patterns that start with a letter. We can choose to find everybody ending with a letter. For example, how many employees end with the letter Y? In this case, we'll put the wildcard first because we're looking for any letters that finally conclude with the letter Y. Execute the query, and you get Barry, Terry, and Sally. Other names that could appear if they were in your database could be Joy, Andy, or Lindsay. Let's take it a step further. Instead of starting with a specific letter or ending with a specific letter, let's look for patterns or letters anywhere in their name. For example, how many employees have a double R anywhere in their name? All you would do is single quote, percent, double R, percent, single quote, and execute the query. You get Barry and Terry. Now this next one is a borderline trick question. Let's say you were looking for people who have an A in their name. Single quote, percent, A, percent, single quote. Now here's the question. We have somebody named Alex who starts with the letter A. We have somebody named David who has an A in the middle of their name. And we have somebody named Lisa who ends with the letter A. Will David be the only one to appear because he's the only one with an A in the middle of his name? Or will Alex appear because there's an A in his name? Will Lisa appear because Her name ends with the letter A. Well, what does the percent wildcard mean? It means 0 or any number and any type of characters. So make a prediction. Run your query. Notice we get Alex. Why do we get Alex? Because this percent sign represented 0 characters before it found an A. For Barry, well, it represented 1, and then it found an A. Lisa, it found an A and then no characters after it. The percent sign represents 0, 1, or as many characters as it needs to find the pattern. Now this might sound like a word riddle, but what if you wanted to find everybody who has the letter A somewhere after the first letter? In other words, no Alex, because he has an A as the first letter, but no letter after the first letter is an A. David, second letter is an A. Yeah, his record should show up. Lisa, the last letter is an A. Yes, we should see her too. So we want to force it to find any letter for the first letter and then an A anywhere after it. So what we're going to do is use the underscore. The underscore is similar to the percent wildcard. It looks for any letter, but it's exactly 1 character long. Now that we've ensured that there's at least 1 letter, we want to look for an A anywhere after the first letter. So we'll type underscore percent A percent and execute the query. Notice we don't see Alex, but we see Barry, who has an A as the second letter, Lisa, the 4th letter, David, Barbara, Sally, and so forth. You can use wildcards and you can use many wildcards together. For example, we learned that A percent finds all of the last names, like Adams, that start with the letter A. If we wanted to find all the names that start from A to B, we can add to our criteria. Or, last name, like, single quote, B percent, single quote, and run it. You'll notice the result set. We have all last names where the first letter ranges from A to B. How about A through K? Well, we can continue this pattern, run this query, and you will notice you get a range of last names from A through K. There's an easier way to do the same thing. By using just one criteria statement, put a square bracket before the A, and a hyphen, a K, and an ending square bracket, and you get a range. Now, what's between the square brackets represents 1 character. So the first character is ranging from A to K with a percent sign single quote. Run it, and you'll have a much easier way to achieve the same thing by using a range. So if you like ranges, there's another type of range query we can do. This one will be querying the grant table. Notice that grants come in different amounts from 4,700 to 41,000. If I'm looking for grants that are greater than 20,000, I can do this. Where amount greater than 20,000. Run it, and you notice that you get only the grants that are more than 20,000. What if you were looking for grants that were between 20 and 25,000? We can type and amount less than 25,000. Let's look for an expected result before we do this. It seems we have 1, 2, 3, 4 grants between 20 and 25,000, but only 3 showed up. With 25,000, I've used the less than. If I want to change this so it's inclusive, we can put an equal sign here and an equal sign here, run it, and now you get all of the grants between 20 and 25,000. There's an easier way to do this. If you say amount and the word between 20 and 25,000 and run it, you get the same range. Using the between with the and is inclusive. What do I mean by inclusive? If you ask somebody to pick a number between 1 and 10, and they answered 1, would that be correct? Yes, 1 is considered to be between 1 and 10. In other words, 25,000 is considered between 20 and 25,000. While you're learning SQL Server and one of your friends or coworkers who's known for being really good at SQL Server asks you, "So what have you learned so far?" See if they know this trick. Start off by doing something fairly simple. looking for all the last names that start with the letter O by going single quote, O, %, single quote, and run the query. Now, why did they run this query? Perhaps they ran this query because they were looking for O'Malley, O'Shea, O'Shanahan. The intention of this query could have been looking for Irish names that start with the letter O and then have an apostrophe. Well, we did find 2 potential Irish names, O'Neill, O'Hare, but we also found Osaka, which is not exactly an Irish name. So there's a pattern we're after, O with an apostrophe. Well, an apostrophe and a single quote are the same thing. So if I put a single quote here, this is looking for an exact O. And this thing off to the right, this % with a single quote, looks like an error. SQL Server says, hey, I got my 2 single quotes with an O on it. I don't know what this thing is off to the right. So what can we do? The first apostrophe needs to be the first delimiter of our string. The last apostrophe needs to be the ending delimiter of our string. But that middle one should not be a delimiter at all. It should be a regular apostrophe. The way to do this trick is to put a second apostrophe after the first apostrophe and disable its special meaning. And now we get the O apostrophe names appearing. Let's use an example from the grant table. Type in select star from square bracket grant, because grant is a keyword. Hit execute, and we notice quite a selection of different grants as a result set. We have % signs, we have @ signs, we have apostrophes, and we can use all the tricks we know to find all the patterns we want. Well, what if we were looking for email names? But now my email name is probably different than your email name. But they have something in common. All email names have an @ sign in them. So a first attempt to look for email names might be this, where grant name like single quote % at % single quote, and run it. Are all the results email names? This is an email name. This is an email name. Now how can you tell that "at last you can help" is not an email name? Email names do have an @ sign, but they don't have any spaces. How can we find all the names with an @ sign that have no spaces? Add and grant name not like single quote % space % single quote, and then run it. Now you notice we have no results that have spaces. We still have results that are not valid email addresses, but we're going to leave a little bit of challenge for you in the upcoming skill check to figure that one out. Time for Lab 2.2, Skill Check 1. You need to write a query on the current products table of the JPro code database. You need to display a result set of all records that have the letter X somewhere in the product name, like Mexico. When you're done, your screen should resemble the figure you see here. Read, review, and complete the skill checks 2 through 8 you see on the screen. Pause as needed until you complete each one. With that practice under your belt, you're ready for the ultimate challenge, which is skill check 9. Imagine you've been asked to create a result set from the JPro code database. You must create a result set that will show all grants that were funded by somebody with a valid .com email address. To succeed, you need to use wildcards. And here's the logic you need to use. Find an @ symbol somewhere in their name. The email address should end in .com. Make sure there's at least one character before the @ symbol and at least one character after the @ symbol, but before the .com. Also ensure that there are no spaces in the grant name. When you're done, your screen should resemble the figure you see here.